All right, so here's some questions from practice test number 2. Make sure you're on the correct one. So first one, I think we'll go after is number 3. So number 3, if you look at it, we have a pulley, a belt really system, and pulley B is being driven by pulley A. So this is my input, this is my output. That's kind of useful. And this is B is a 16-inch diameter, and A is a 4-inch diameter, not meters. So first thing it says, if pulley A is spinning at 60 RPMs, then pulley B is spinning at blank RPMs. First thing I want to figure out is the gear ratio. In gear ratio, you can either use teeth or torque or RPMs or diameters. So this one's going to be diameter out over diameter in, or out over din. So for this problem, you have out is 16 inches, in is 4 inches, so it's a gear ratio of 4. Well, how does that help me? I asked about RPMs. Well, you should also know that gear ratio is win over wout. It's the one weird one. There's our angular velocity. Whenever you see RPMs, this omega sign, and it's basically everything flipped upside down. So I can put the answer for gear ratio of 4 input. So I can put my gear ratio as 4 because I just figured that out over here. That doesn't change. And then it says if pulley A is spinning at 60, well, which one's pulley A? Pulley A is my speed of my input. And then the thing I care about is in bottom. You do the old Western switcheroo, and omega out equals 60 RPMs over 4, which is 15 RPMs. There's your answer. And that brings us to number 4, so I might as well do it. Which one of these is not like the other? And all these are out over in, out over in, out over in, except RPMs. But you got to remember the RPM fancy name is angular velocity. The symbol's like an omega. Okay. And this one I wanted to bring up because you just got to common sense your way to the answer here. If friction is included in a simple machine, the amount of effort required to move something will be blank to what is calculated using formulas. So think about it. In reality, will it take more or less effort to do something if there's friction? And if you think about it for a second, you're like, it's always going to be a little harder because you're wasting some of your energy on friction. So the effort required to move it is always greater than what's calculated in the formulas. It can't even be equal to. There's no such thing as a 100% efficient machine. So that's kind of your clue there. All right, and then this page, we'll jump down to here because I wanted to do one of these ramp ones, inclined plane. So ramp is used to raise something 3.0 feet off the ground. The base of the ramp is 10 feet long. And if you just use those numbers, you're going to get it wrong. You need to always find the diagonal of a ramp. So you got 3 squared plus 10 squared equals c squared. And then, what's that, 109. So c is the square root of 109, which, we'll figure out what that is. The square root of 109 is 10.44. Keep those numbers in my calculator. So this is 10.44 because IMA equals, I'm a deer, I'm a distance effort over distance resistance. So in this one, IMA is going to be my distance effort. I push the box up this way. This is my DE. Not the 10, but the 10.44. Guarantee one of those answers, is this feet? Yeah. One of those answers is if you use 10. 10.44 over 3.0 feet. So this is what you're lifting. You're lifting a box up 3 feet, but it takes 10.44 feet of sliding. So you do a little calculation. I just have that old number in my calculator, divided by 3.0. I get 3.48. No units. There's my winner. Okay. I bet one of these numbers was if you use 10. Like 3.33 is probably if you use 10. Yeah, it was. All right, then we go down to here. Just wanted to bring up a screw problem again because it's been a while, and sometimes there's extra info in these. So what's the mechanical advantage? It still is, I'm a deer. But remember, when you're doing effort, you're talking about like how much it takes to spin that. That's circumference. When you're talking about resistance, it's how far down it moves, which is pitch. And circumference can be written as 2 pi r, or pi d. We'll figure out which one we want. And the bottom, pitch, is 1 over teeth per inch, TPI. Okay, so we're going to make this crazy equation by reading through here and getting what we need out of it. It's a 3/8 inch diameter screw with 20 threads per inch. Okay, I know I'm going to steal that and put that down here. If a 1.5 inch diameter screwdriver is used, so I don't want the 2 pi r, I want the pi d. So we're going to go IMA is pi times 1.5 inches over 20 threads per inch, but it's 1 over 20 threads per inch. So inches are going to cancel with inches. Make sure you type this in with parentheses galore. So we're going to go pi times, oops, I need parentheses, 1.5 times pi on top, and 1 over 20. 94.24. Yeah, rounded to the nearest whole number, 94. Okay, now we're to the back. A couple of problems here. Wanted to do one simple gear train and one compound gear train. So simple gear train is just in a row. Gear A is 10, gear B is 8, gear C is 20. Now, it's important they told you which one's the output. There's the out, there's the in. Because gear ratio is nout over nin. So teeth out over teeth in. So I'm going to go 20 teeth divided by 10 teeth. And you get a gear ratio of 2. And then it goes into 2 other questions, which are always good because you can always set it up. You'd be like, okay, if you ask me about RPMs, I need to remember gear ratio is the weird one. It's win over wout. So it says if A rotates at 60, so that's my input, then my output is the question mark. I should just rewrite this again. Instead of gear ratio, I get to put a 2. So 2 equals 60 RPMs over wout. Do the old Western switcheroo. And you get 30 RPMs. So it's going to slow it down, which makes sense because you're going to smaller to bigger. The other way, torque, what happens to torque? Well, I got a different equation for that. So win over wout, or nout over nin, I got tout over tin. Torque out over torque in. So in this problem, I still know my gear ratios too. That doesn't change. I just need to know, did they give me tout over tin, or which one did they give me? They gave me torque on C. That's torque out. 150 foot-pounds over tin. And you're going to do the old Western switcheroo because it's on bottom. And tin, or torque in, is going to be 150 foot-pounds over 2, which is 75 foot-pounds. And then you can do that one. Here's where it gets a little weirder because this is a compound gear train. Because these two are joined on one axle. So they gave us all the teeth. You got 10 for A, you got 20 for B, you got 16 for C, and 40 for D. Find the gear ratio. Well, this is different because it acts like 2 separate gear trains because of this nesting that's going on. So you can't treat it like, you can't just do out over in because it's not a simple gear train. So you're going to go, you're going to do the gear ratio equals nout over nin for A, B, times nout over nin for CD. So you have to do the two separate units separately. So in this problem, you're going to go 20 teeth over 10 teeth times 40 teeth over 16 teeth. You do top times top, bottom times bottom. We're going to get 40 times 20 equals divided by 160. So we get 5. Nice gear ratio of 5. You would have said 4 if you thought it was a simple gear train, and you'd be wrong. And then you can do the same stuff up here. If I know my gear ratio is 5, I can answer any questions about torque and RPMs and diameters and all that stuff. So you just got to like take a second and write your equation. Tout over 10. And you got 5 equals, and input torque is 100 foot-pounds. And we got tout. So we multiply both sides by 100, and you get torque out is 500 pounds. Foot-pounds, sorry. Okay, and yes, I think, I don't know, I think we got all sorts of good stuff there. So check the answer key for other stuff. That's kind of the video for there, and I will talk to you later. Let me know if you have other questions, and I can go over any you want.